Okay, guys, let's continue. So, card number 5. They give us a function, and they tell me to determine the domain. So, you guys, I usually, whenever I have to talk about domain or possibly range, which is in the next question, they talk about it, I like to sketch a graph, okay? However, the way they gave this equation, I would not try to sketch it unless you're going to use a table. Unless you're going to see that, okay, I can plug in 7 for x and numbers less than that, so I could plug in 6. If you do the table way and make a sketch, I like it. But if you're going to try to do it the transformation way, I don't like it. The reason for that is this is funny. Okay, we cannot see what transformations are truly happening this way. We have to rewrite this as negative x plus 7 first. And then we still can't see what transformations are truly happening because remember I told you this needs to be in parentheses. So that negative needs to be factored out. If I take a negative out of negative x plus 7, I get that. And so this function really should have been written as c of x equals 3 times the square root of negative x minus 7. Like that. And then I would trust a sketch made out of transformations. But I feel like it's just not worth it. So if we go and we just try to look at the function, we can figure it out. If you want to make a table, I'm also okay with that. Okay? So, and then sketch a few points. I'm trying to decide if I should do it or not. No, I would say make your sketch, make the points, graph your function, and then see how it matches up with what I get when I look at this one algebraically. I'm just going to look at it algebraically. So domain, you guys, is a set of all x's. For this particular function, I can tell that the starting point, that I can plug in a number, or one of the boundary lines, I should call it, is 7. Because I can plug in 7 for x, and I would get 7 minus 7 is 0, and square root is 0. That's fine. However, if I go any bigger than 7, it's not fine. Greater than 7 is not okay. Anything else is okay. Greater than 7 is not okay. All right, the reason being, if I put in any number bigger than 7, when I do 7 minus that number, I get a negative. And the square root of a negative, we can't do. So that right there just tells me my domain, essentially, you guys. The domain is any number that's less than or equal to 7. That excludes anything greater than 7. So x less than or equal to 7. Boom. Domain. Done. Okay, now they want me to come up with a value that's not in the range. So my understanding of a square root function tells me that they kind of begin somewhere. I'm not saying this one begins here. I'm just saying they begin somewhere, and then they kind of head off into a particular direction from there. Now, they could go up. They could go down. They could go down to the left, or they could go up to the left. So they can go in any direction. However, the point is that they go in a particular direction. What that tells me is that this boundary line right here, which is 7 for the case of this function, 7, is where both x and y values kind of begin. If I look, see, whatever that y value is, anything under it in this case is not part of the domain or the range. Or if it went downward, then anything above this is not part of the range. So I know that the boundary line of the range is whatever the y value is when I plug in 7. So let's plug in 7. C of 7 equals 3 times 7 minus 7. 7 minus 7 is 0, and the square root of 0 is 0. And then 3 times 0 is 0. So that means that that point right there is 7 comma 0. And in the case of this particular function, because there's no vertical reflection, the function still does go upward. So that means that I just cannot achieve numbers less than 0. So the range is f of x greater than or equal to 0, which means any number less than 0 is not part of the range. So not -1, not -2, not negative anything. Okay, that would be the answer to B. Any negative number. Let's just go with -1. Okay, so I do think that that was a, if you're like a super algebraic person, maybe that was chill, but otherwise I feel a little bit like maybe the sketch would have been good. So let's do the sketch. Let's do it really fast. This graph right here, let me build that table that they make. This function goes x, then it goes 7 minus x, then it goes the square root of 7 minus x, and then it goes 3 times the square root of 7 minus x. So I want the thing that I square root to be nice numbers. Nice numbers to square root are 0, 1, and 4. Okay? So I want 7 minus x to be 0, 1, or 4, so that when I have to go square root it in the next step, it comes out nice. So in order to get 0, 1, and 4, I need x to be 7, because 7 minus 7 is 0. I need x to be 6, because 7 minus 6 is 1. And I need x to be 3, because 7 minus 3 is 4. Now remember I told you if picking the perfect numbers is going to be really difficult for you, just make sure you start at that 7 boundary line. So looking at what makes under your radical 0, you're going to start there. And then you can pick other numbers that are okay to plug in to build out the rest of the function. And if it comes out to be a decimal, you're just going to have to sketch it that way. Okay, but now the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And in the final step, all we're doing is multiplying by 3. So 0 times 3 is 3. 1 times 3 is, 0 times 3 is 0. Holy moly. 3 times 1 is 3. And 3 times 2 is 6. And that means that I've got ordered pairs. This and this. These are my x's. These are my y's. So making a quick sketch, I have the points 7, 0. I have the point 6, 3. And I don't really even need the last point, but let's do it. 3, 6. Here's the square root function that I've got. Okay? So now looking at the sketch, I can tell that the domain is x values that are less than 7 or equal to, and that the range is y values that start at 0 and go up, so positive, so greater than or equal to 0. Okay, let's move on. Sketch the graph of this guy. All right. You know, I just did a sketch using the table. So in this one, I'm going to do it using transformations. This guy has a parent function. That's the cube root. That's the most basic version of this function. And what it looks like is that. Okay? It goes through 0, 0. It goes through 1, 1, and so on. Okay. What I have here is a vertical reflection and also a shift or a translation to the right 4 units. So I'm just going to put all this on a graph now. This guy is going to be flipped upside down, like that. And then it's going to go to the right 4 units. So 1, 2, 3, 4. This point is going to go here. And it's going to look like this. Okay. One thing I would look for is that it does a up 1 over 1 kind of a deal. Down 1 over 1 kind of a deal. Because it did not have a scale, no scale. So I should not see it getting shrunk or stretched. So I don't want to see it bigger or smaller than the original. It should be the exact same size. And the original goes up 1 over 1. This one will go up 1 over 1, down 1 over 1. Here's an unfinished table and a graph for 2 different functions. Complete the table so that each function does not have an inverse. Not having an inverse means can't have the same y, right? If we fail the horizontal line test, that's because we have 2 points whose y value is the same. So we need same y values. All right? So for 1 and 0, if you put another 1 or 0 somewhere, you're good. Okay? And put them both. Or if you want to get really creative, make them something different but both the same thing. 3 and 3. So that, again, as long as you have the same y value, you're good. And the x doesn't actually matter. Make it whatever you want. On this guy, if we want this guy to fail, we need him to fail the horizontal line test. So bring it back up somehow. And then do whatever else you want from there. All right? Okay. That's it. Here's a graph of a square root function. Let's write the equation. Love it. Let's see. The typical square root function, 0, 0, 1, 1. Remember, I talked to you about that here. Almost every function almost starts that way. Every parent function almost every parent function starts that way. Boop, boop, boop. So let's see what I have. What I have is a horizontal flip. Boop, 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 boop. Reflection. And then I appear to have a shift of down 1, 2, 3, 4. And 2 to the right. And notice how from this point, it does go up 1 over 1. So that means there's no scale, right? So this is all that has happened. Just the reflection and the 2 shifts. So the equation is going to be P of x equals the square root of, okay, a horizontal reflection is a negative on the inside. Oh, you can't see what I'm doing. There we go. We got the square root. I got room in the front, room in the back. We're going to put everything on here. Okay, so a horizontal reflection means negatives on the inside. And that means you're going to need parentheses for whatever x is doing. Then we have x. And the shift of 2 to the right gives me a minus 2 with the x. And the shift of down 4 gives me a minus 4 at the end. Nothing else, nothing in the front. There's no scale, there's no vertical reflection. We're done. And now I have a graph to sketch. It's a square root. So the parent is y equals square root of x. So it goes through 0, 0, and 1, 1. And if you want to be a little bit more specific, it also goes through 4, 2, because the square root of 4 is 2. And the parent function looks like that. And then my function also has a scale of 3, means it has stretched vertically, triple, 3 times, and it also goes down 2. You guys, this 2 is not in the radical, so it's part of our vertical transformations. Okay, now what does the scale of 3 do? The scale of 3 makes me go 0, 0, but then instead of going up 1 over 1, I'm going to go up 1, 2, 3 over 1. All right, so my new function is triple the height of the parent function. Even here, this guy's height is 2. Mine is triple that, so 3 times 2 is 6. If you want to keep going, if you want to be more specific, but be really careful about these two, and the rest should be okay. But this is what the parent function looks like after that vertical scale. And then now all we have to do is move this down 2. So this point goes down 2. This point goes down 2. This point goes down 2. And so the final graph of this function is the red. The graph of m of x contains those 3 points. Select all the points that are on the graph of the inverse. You guys, we don't know what m of x is. We cannot come up with any points beyond the ones they gave us, okay? And so all I know about inverses is x and y are switched. So the only points that I could agree to are the ones that are x and y switched of these. -1, 0, 1, 2, 0, 1. They're the only ones, all right? If it's not one of these 3, it's not a correct answer. So C is good, B is good, D is good. No. At least I don't know. Okay, that's it. Just B, C, and D. That's it. Okay, you guys, that's all I got for you. Good luck.